Hi everyone, here I'm going to start topic 10, regression. So, professionals often want to know if there is relationship between variables or if variables are related. Okay, so I just zoom here. Okay, yeah. So, for example, is there a relationship between the grades on second math test that a student have and the grade on the final test? If there is a relationship, how is the relationship? Is it strong or weak? Okay. When one variable, commonly y, is dependent on another variable, commonly x, like for example y equal fx that we talked about it, okay, which is a function, or for example like lines y equal mx plus b. We say x is independent, we can choose just x independently, and y is dependent to x. Okay, y is dependent. So if the relationship is linear, okay, so the relationship can be shown like this. Okay, now I can talk about a slope. So m is a slope and b is y-intercept. That's the same, that's a line. Okay, so now if m is 0, the slope is 0, so means the line is horizontal. Okay, so the line is just a line parallel to x-axis. This says there is no relationship between two variables. If I have a slope positive, the relationship is, so the slope is positive and the relationship is they vary directly, the same as last semester. I think it was topic 7 or 8 last semester, we talked about variation. They vary directly. Okay, so means if x goes up, y goes up. If x goes down, y goes down. The same as each other. If m is negative, it says so varies, so variation. Okay, so it varies inversely. So means when x goes down, y goes down. Okay, and when x goes down, y goes up. X goes up, y goes down, because it's inversely. They just change and just opposite of each other. Okay, usually data they don't fit on a straight line. Okay, in this case I think about line of best fit or regression line. So we have several types. We can talk about one of them here. Okay, so if I have x and y, in many cases I don't have exactly line. Okay, so I just between them I just so I just want to find the line of best fit. Okay, so just 1 second, I want to, okay, so I want to check something here. Okay, so yeah, okay, so now I continue. Before we talk about, let me see, yeah, okay, so before we talk about and we discuss about the regression line, and so just we discuss about these things. we want to show how we show the relationship between x and y. For example, let's say I have x as years here, x as years, and then I have y here as number of users, for example. So year 2000 we had so almost just no user, half a user, and then we went up, the year just increases, the number of users increases. How do I show it? We can talk about a scatter plot. You can ask Excel to do it for you, okay? But you need to know what's going on behind the scene, okay? So we can show it this way. So I can show it with two-dimensional graph. So x is, for example, horizontal, y is vertical. So I show the value of x on horizontal, the value of y on vertical, and then I find this point, okay? This point is for the year 2000, the number of user is 20. Okay, so I find 2020, 2002 on x and 20 on y, and then I find the point. The same as in Math 171, we talked about graphing. Okay. So before I continue, I want to show you just different type of scatter plots. Okay, so for example, you show x and y, x on x-axis, y on y-axis, or one variable on x-axis, one variable on y-axis, and then you have different type of scatter plots. For example, one scatter plot can be like this. It's positive. Why positive? Because you can see as this is increasing, this is increasing as well. So we say this is positive. So you can see the slope is positive, the slope of the line. Do you remember this from last semester? When I had this type, the slope is positive. This type, the slope is negative. Okay, so here a slope is positive, here a slope is negative. So I can see the first one is positive, okay, and it's strong because they are very close to a line. So we say that's strong. This one, B is also linear pattern because they almost lie on one line, but one of them, one deviation is far. So we say with one deviation. This one, again, A in the second row is negative because it's going down. Okay, so the slope is negative. So negative, but it's still strong because they are close to one line. This one is negative but weak because they don't lie on one line, so far from each other. Okay, if I make a line of best fit, so I cannot have many of the points on the line. Okay, here for the third row, or for the first row in the next page, I have A like exponential. That's exponential. They don't lie on a line at all. Okay, that's exponential growth. B means no pattern. There is no pattern here. There is no pattern here because as you can see, it jump up and down. There is no pattern. Now we want to, okay, so let me just zoom out. Okay, and then if I can, okay, so now as I said, for many datas, okay, so when I say what is the relationship between x and y, they don't lie on a straight line which fits all of them. Okay, so I want to find line of best fit or least square line. Okay, so one of the type is least square line, so I can find this. So let's do it on this example. For example, I have the first column which is grades for one exam, third exam, and the second column is for final exam. Okay, this is out of 80, that's out of 80, this is out of 80, and this one is out of 200. Okay, so I have values. I make one of them on x-axis, the third exam on x-axis, the final exam on y, and then I find those points. Means, for example, this point is 65 and 175 for final exam and 65 for the third exam. Okay, you find all of the points the same way. Okay, as you can see, they don't just lie on one line. Okay, so you can't find a line of best fit that have all of them on it. So then what should I do? So I want to make a line of best fit. The type that I want to choose is least square. Okay, so least square line. Okay, the least square line is here. How to make line of least square? Okay, the yellow one is line of least square, a plus bx. A is like y-intercept, b is like a slope. How do I find a? A is in the second row. A is y bar minus bx bar. Y bar is mean for y, means you add them all and divide by the number. X bar is you add all x and divide by the number of x. And also you need b to calculate a. What is b? B is in the third line. In order to do all this calculation, I use Excel and I just copy paste the table here. You can do the same thing. See, the first column is x. So this is x, the first column. Then I have y. Okay, so maybe okay, I just stay with those colors because okay, yeah. See, this is all x here, and then I have y. Then I calculate x bar, then I calculate y bar, which means all x you add and divide by the number. Okay, yeah. So then we do x minus x bar because we need it for b. Then we do y minus y bar, and then we multiply them because we need it for blue part. Look at this part, we need it for this one. See, look at this, look at this one. So you need it for that blue one there, because you have to multiply x minus x bar with y minus y bar for one by one, and then you sum. The summation is in here, the summation is in here, because I add them all, I add all of them here, I add all of them here, and when I add them all, it goes here. Okay, then I do x minus x bar squared, and again I add them all. It goes here, which is the pink one. Then I divide to find b as a slope. These two, which I use here, these two, if you just look at here, I wrote. These are not subtract. It's not subtract. I just wrote a slope hyphen b because a slope is b, and then I calculate y-intercept. Okay, so the formula will be given to you. Okay, and you can just calculate using your calculator. So for sure, it won't be too many data. Okay, so won't be very large. Okay, so if you remember, I am using from the same example. So this is test number 3 and this is final exam. Okay, now I see this is the line of best fit. Line of best fit is here. Okay, so it is where is y-intercept? Okay, minus 1 minus, okay, so it is here, minus 173.5 plus 4.827 x. Yeah, so this is y hat. Okay, so that's y hat, which is the line of least square. Okay, So that's line of least square, and I can ask Excel to draw it for me. Okay, see, it has some of the data on it and some of them are far from it. Okay, for example, this one, which was 65 here and 75 here, this one, so it has 1 point on the line, but the real point is out of the line and far from it. Okay, so far I talked about, okay, let me see. So far I talked about the relationship I can have between two variables, and if it is a line, how the line look like. But in most cases it's not a line, so I want to find line of best fit. Here I do least square line of least squares. Okay, and this is the formula. Okay, so we use the formula. Then the important part of the lesson is, for example, one part of the first part is, for example, okay, if I give you the data and if I give you the table, if I give you the formula, yes, of course you can calculate. You have the formula, you have the data, and you can calculate line of least square. Okay, line of least square is here. Okay, that's here. Oh, okay, a slope is 4.83 and y-intercept is minus 173.51. Okay, the first important part that you need to know from this lesson is understanding the slope. And understanding the slope comes from last semester. Do you remember? A slope was rise over run. So for run, I go to right. For rise, I go up and down. Depends on being positive or negative. What is the slope? A slope is 4.83. Oops. A slope is 4.83 divided by 1. Means if I go on x, if I go 1 to right, I go 4.83 up. Okay, so let me okay, so let me just zoom in. Okay, yeah, it's fine. Okay, so look at this. The first important part of the lesson is here. The lesson, for example, I can give you the data, I can give you the formula, you can calculate, but the most important part is understanding. Okay, so what does this mean? Here, see, for one point or for 1 mark increase I have on test, I have on third exam, we have 4.83 marks increase on final exam. Okay, on average, that's average. Okay, this is meaning of a slope. So if you understand meaning of a slope, you can explain it in sentence. Okay, so the slope means if I have increase for 1 unit on x, because it is this rise over run, so x I go to right for run, then I go up for rise. Okay, so here I have, if I have increase on, for example, if I have increase on just one increase on x-axis, which is the third exam, I have this increase 4.83 on y, which is final exam. Okay, so this means understanding the slope. You're understanding the slope. Okay, how y is changing when x is changing, how y is changing when x is changing 1 unit, just 1 unit. Okay, so this means understanding. So, and you are explaining, not just saying when x goes 1 to right, y goes 4.83 up, because I know it's positive. No, you understanding based on, so you explain based on the question. Okay, 1 point increase on third exam, it will increase the final exam 4.83 just on average, okay, the final exam. Okay, so that's important. Okay, so 1 second here. Okay, so I have to, yeah. Okay, so let me see. Yes, X and Y. Yeah. Okay, so the second important, so second thing which is important here is this one. So residual. Okay, define residual. What does residual mean? Residual is the difference between real value and the value related to that on the line. See, for example, let me see, here is, okay, yeah, see, look at this. So this is 65 and 175. Was it, or what was the or maybe another. Okay, so 1 second. Okay, so I can check here. Okay. Oh, sorry, yeah. Yes. Okay, so look at this. This here. Okay, this. Look at this. This was the real point. 65 and so 175. Look at this. So 65 and 175. Okay, I can find residual. Residual means error, means what is the difference. Okay, this part is residual. So what is the difference? This part, which is what is the difference of y for related to that x on the line. Okay, so what is the line? So the line is minus 173.5 plus 4.8 3. So let me see. Yes, 83. So minus 173.5. Okay, 51 and that. Okay, so here is just because we round, so I want to check. Okay, so that's 4.83 and 173.51. Okay, yeah. Okay, so this is the line. Okay, this. Okay, then I ask you, okay, what is y hat related to 65? So you say, okay, I just calculate this. Okay, which is just for that. You expect the result to be less than 150 because you can see it is less than 150 here. Okay, so what is the result? So 65 multiple 4.83 minus 173.51, which is 140.44. Okay, so 4.83 times 65 minus 173.51, 140.44. Okay, so this is y related to that x but on the line of best fit, but real y related to that x is 175. And if I find 175 minus 140.44, that's the residual or the error for that point. Okay, so this is number 2 that you can understand and know about this lesson. Because this lesson, I can give you the formula, I can give you the data, you can calculate. But I want you to understand what's going on behind the scene. You can use Excel, okay, for the calculation. So, okay, so this is the second point, important. Now, okay, Now, correlation coefficient. Besides looking at the scatter plot and see if I have line of best fit, or if not, I can just find it. I can use correlation coefficient to say what is the relationship between X and Y. Okay. Beside that, I can use correlation coefficient is another thing to show you how strong or how weak is the relationship between X and Y. Okay. So how do you calculate correlation? The formula is given here. The formula is here. Okay. So let's see. Okay, here I add all X, here I add all Y, and I multiply them with each other. Here I multiply them first and then I add them all. And here I use N and I just find the top. For the denominator, I use radical, two brackets in multiplication. The first bracket is N multiple. I do X squared one by one and then I add them all. Here I add them all and then I do a square. Here I do the same thing for Y. I square and add them all here. So maybe I change the color. See, here I square and add them all. Here I add and square. Here again I square and add them all. Here I add them and square. Okay. So yes, I can give you the formula. I can give you the data. You can look at the formula. Make sure to do practice on it. You can use Excel. But the most important part is understanding what's going on. Okay, what's going on. So this is the third thing that you can know from this lesson that's important. Okay, what is the property of this R? Okay, the properties of R is from -1 to 1. Okay, so these are the properties. If R is 0, there is no relationship between X and Y. If R is -1, they are changing inversely as each other, and the relationship is strong. So one of them increases, the other decreases. See? Okay, here. If R is 1, again it's strong but directly, means both of them increase or both of them decrease, that directly. Okay, in most cases I don't have R exactly 1 or I don't have R exactly -1. So I just say, okay, how close is R to 1, how close is R to -1. Then I can say it's strong or not. If R is positive, I say directly. If R is negative, it's inversely. Okay, so I can know these things. So the sign tells me direct or indirect. So if it is positive, X increases, so Y increases, and X decreases and Y decreases, the same as each other. Okay, so these things, if you have to understand this. Okay, so as I said, I can give you the value. I can ask you find R and tell me is it strong or not. But how do you, so what do you say about it? Do you understand or not? I don't want you to forget it. So if you understand, then you don't forget. So what's going on? Okay, what is the meaning? So look at, let's just look at several R. Okay, see, this R, it's 0.8. Okay, so it's not close to 1, but it's a positive correlation because it's positive, and I cannot say it's strong because it's not close to 1, but it's not that bad. The second one is very close to -1. So if you look, yes, they are close to a line. So it's a strong negative correlation. Means one of them goes up, one of them goes down. See, one of them is increasing, and the other is decreasing, coming down. Okay, and it's very strong because it's close to -1. This one, it's almost close to 0 because it's 0.05. It's very small. And make sure that you pay attention. For example, if I give you this is very weak. But if I give you this is strong. Okay, so pay attention how many digits you have. Okay, these are not like each other. Okay, so then I can say which one is okay. So by looking at the correlation, I can say, okay, so I want to show you on a scatter plot, and I want to show you on the data to tell you what does this mean. Now I am calculating R for the value of test number 3 and final exam. I am calculating this. So I multiple xy, y because I need it for top. Look at this. See, I need it for top. This is top here. Okay, I multiple them and then I add them. See, this is addition. And here I add them all here, and I add them all here, and I just find top. Okay, numerator. That's numerator. So that's just the top value. Okay, so this is just the top value. The top is here, numerator. Then I do calculate for the bottom. Okay, denominator, and then I find R. Look at R. R is 0.66. Yes, it's positive correlation, but it's not strong because it's not close to 1. Okay, not strong. Okay, the next page again is fourth part of important information. What do we need when we say, okay, R squared is this? Okay, what does this mean? Let's say I calculate R, then I find R squared. R squared tells me, I just zoom in. Okay, R squared tells me that's coefficient of determination. Okay, so when I calculate R squared, okay, it shows me, okay, for example, as I have to express it as percentage. Okay, it shows me how many percentage, okay, are related to each other. See, represent the percentage of variation in the dependent variable y that can be explained. Okay, so this percentage of y, they can be explained by change on x. 1 minus R squared, which is the rest, okay, they cannot be explained by so values on y cannot be explained on value from values of x. They cannot be explained. Okay, so this one, yeah. So this is the fourth thing. Okay, look at what I did for test number 3 and final test example. See, this is line of best fit. Do you understand? Yes. Okay, one change on test number 3 makes 4.83 changes on final exam on average. Okay, when I look at this, I understand this. Then correlation, I calculate correlation. What do I understand from correlation? Correlation is positive, means x is increasing, y is increasing, but it's not strong. It's not strong. Okay, so I understand that. I also can talk about residual for any points, which I did. So number 1 and 2 I can be explained here. Number 3 can be explained here. So what does correlation correlation coefficient mean? Oh, it's positive. It's both of them are increasing, both of them are decreasing. They varies the same as each other. They are proportional. Directly, they are changing directly. Then I calculate R squared. When I calculate R squared, it is this, and I can round it to 44. Okay, I can round it to 0.44 0.44, okay, so 1 second, 0.44, which is 44%, okay, 44%. So 44%, okay, so this is the fourth that I can explain here from this page. 44%, okay, in the final exam can be explained by variation made on the third exam, because it wasn't really strong, okay, and as I said, the correlation coefficient is not close to 1, okay. The rest, which is 56%, they cannot be explained by each other, okay. So on final exam they cannot be explained by test number 3, okay. So 1 second, so we are done here by this lesson. So again, here I can give you the data, I can give you the formula, you can calculate, okay. If it is large, we can use Excel. If not, you can do the calculation. But the most important is you understand what's going on and what does each mean. Thank you so much. Bye.